We're starting section 6.7 on determinants and vector products. The goal of this section is to compute the cross product of two vectors in R3 and the triple scalar product of three vectors in R3 using the determinant. Subsection 6.7.1, the cross product and the determinant. Proposition 6.7.1, if vector u is u1, u2, u3, and vector v is v1, v2, v3, if we allow a mixture of vectors and scalars as entries in the same matrix, then u cross v is the determinant of I hat, j hat, k hat, those are the vectors, u1, u2, u3, the components of u are scalars, v1, v2, v3, all within the same matrix, where we remember that I hat is the vector 1, 0, 0, j hat is the vector 0, 1, 0, and k hat is the vector 0, 0, 1, the standard unit vectors that we saw in our unit on vectors. Proof. Well, let's remember what the formula for the cross product was. So we calculated the cross product as the following. So u cross v, we wrote the vectors vertically, u1, u2, u3, v1, v2, v3. We recopied the first two entries of each. So u1 and u2, v1 and v2, we crossed off the first set of entries and we did the cross motion. And so we get u2 v3 minus u3 v2, u3 v1 minus u1 v3, and lastly u1 v2 minus u2 v1. So what we want to do is calculate this determinant and make sure that we get the same answer. A little bit of a reminder that if we had this notation, if we had a vector A, B, C in our regular component notation, that could be written as A times I hat plus B times J hat plus C times K hat, because that is going to be useful using the cross product in this determinant. So if we recopy, so I hat, J hat, K hat, u1, u2, u3, and v1, v2, v3, we're going to do cofactor expansion along the first row. So we're going to have our grid plus, minus, plus, and so our cofactor expansion is going to be the entry, so I hat, times the minor, if we remove the row and column of I hat, so we have this little minor here, so u2, u3, v2, v3, minus j hat, and we remove the row and column of j hat, so we're getting u1, u3, v1, v3, so u1, u3, v1, v3, and then finally plus k hat, and the minor, when we remove that, u1, u2, v1, v2, u1, u2, v1, v2. So calculating this out, remember these are 2 by 2 determinants, and so we can do the same little cross motion. So we're going to get u2 v3 minus u3 v2 times I hat minus u1 v3 minus u3 v1 times j hat, and plus u1 v2 minus u2 v1 times k hat. Now this is exactly the notation that we have up here, so we can put that into a vector. So the first component is multiplying I hat, and so we're going to have u2 v3 minus u3 v2. The second component is multiplying j hat. I'm going to distribute in that negative. So negative, negative here is going to give me u3 v1, u3 v1 minus, and then u1 v3. And then the last component is multiplying k hat, so that's going to go down here. And that is u1 v2 minus u2 v1. And if we look, that is exactly the same vector that we got out of the cross product, and so the determinant of this strange matrix, which mixes ij and k hat with the components of u and v is indeed equal to the cross product.